Thank you, Rick, and welcome everybody. This is a great pleasure for me to join you today for the first in our new series of webinars called the e-Symposium series. And the intent of this series is to offer you a chance to meet some very innovative researchers, practitioners, and thinkers in the world of mathematics and mathematical modeling. And today we have such a distinguished guest, Dr. Venkat Crovey. And you'll get to him. We'll get to him very soon. But I did want to give you a couple of comments to help frame this presentation in your minds a bit. And a lot of it has to do with some very recent developments at Maplesoft. First of all, the product line has grown significantly over the past few years. Maple 10 and Maple 11 definitely was a departure from the past versions of Maple, with many more features to make it a lot friendlier and more applicable to the engineering world and the modeling world. Following that, we released a wide range of add-on products that really helped people in modeling and simulation develop much more complex, higher fidelity models. Tools like Dynaflex Pro, Block Builder, and other engineering toolboxes all fall into that category. So in terms of the product line, we're substantially richer today than we were in the past to be able to deal with engineering modeling. More recently, we experienced some great news. We established a multi-year relationship with Toyota in Japan, and together we are developing a full range of innovative modeling tools that apply advanced mathematical concepts and advanced symbolic computation concepts for modeling applications. Now, you're going to hear a lot more about things like that as time goes on over the next months. This was announced later last year. Concurrently with that, we also, along with Toyota, founded an exciting new consortium called the Physical Modeling Consortium, which is an industry group association of OEMs, or the auto companies, as well as innovative solution providers and researchers. And we're bringing these people together to meet the challenges, the research challenges of advanced modeling for the future, and with the emerging engineering challenges that the many industries face today. And that is, in fact, one of the reasons why we have our invited speaker today, as he is definitely one of the leading people on the research side of modern modeling. The conclusion from all of this really is symbolic computation, which, although it's an established technology, for the longest time was pretty much specialized set of tools used by certain types of mathematical research and education. But today it's really substantially different. It has now been widely adopted as a truly enabling technology that is something that helps you do very important things that people were not able to do in the past. And a lot of these applications feed directly into the next generation modeling challenges that industry faces today. So overall, that's the motivation for the kind of topics and the discussions that you're about to hear today. And we're very fortunate to have the speaker that we have today, Dr. Venkat Crovey. He's an associate professor in the Mechanical and Aerospace Engineering Department, and he's also the director of their Automatic Robotics and Mechatronics Laboratory. Further, he's the director of the Haptics and Robotics portion of the New York State Center for Engineering Design and Industrial Innovation. A very accomplished gentleman indeed. His research focuses on the complete life cycle treatment, that is design, modeling, analysis, control, implementation, and verification of mechanical and mechatronic systems. His current research initiatives include multi-robot collaboration, human-computer interfaces for mediated teleoperation, haptic user interface design, and distributed real-time simulation of control systems. Dr. Crovey earned his master's and PhD in mechanical engineering from the University of Pennsylvania. Now, the focus of his talk today will be some of his recent research on the development of high-fidelity simulation models for the haptic or touch sensory feedback for steer-by-wire systems in automobiles. He'll review both the theoretical and computational aspects of modeling such complexity. And in the end, this type of technology is destined to assist auto companies in enhancing the drive experience for their customers, as well as auto performance and, of course, to increase safety. So with that, I will ask Rick to pass presentation control to Dr. Cravey, who's joining us from the State University of New York in Buffalo. And Dr. Cravey, if you can now share your desktop so that we can see your presentation.
Hello, Tom.
Yes.
I hope you can see my desktop now.
We can, and we can hear you as well.
Okay,
everything's
great.
fine.
Thank you for the kind introduction. Good afternoon, everybody. My name is Venkat Cravey, and I'll be talking today a little bit about some of the work that we have done in haptic-enabled steer-by-wire systems. But before I get started, I wanted to give people a quick overview of some of the research activities that Tom alluded to. Details of a lot of these activities can be found from the website, from my lab's website, mechatronics.eng.buffalo.edu. And I'd invite everybody here to come and take a look. And before I get started with the actual presentation, I need to give credit where credit is due. The work that you're going to see here in today's presentation is due to a lot of hard work by these following sets of students, and I just wanted to acknowledge them quickly. So, today's talk is actually going to be excerpted from the thesis presentation of one of my students, Anand Nayak, who defended his thesis in February 2007. I'll also grab a couple of slides from another presentation I made, which is reported in this article. And so both these would now serve as good sources for further details if people are so interested. In terms of an overview of today's talk, there are 5 main sections, and I'll try to keep the discussion at a somewhat higher level, and if people would like further details, I'd be happy to